Again, welcome to College Algebra. In these lectures, we're going to study about transformations of the graphs of a function. This is our Unit 3, lecture number 2. So our main objective is to use the vertical translation to graph functions. Again, use vertical translations to graph functions. Also use horizontal translations to graph functions. Also, we are going to graph functions using two translations. And also we're going to use reflections about x and y axis to a graph function. So first we start with the using the vertical translation to graph functions. And here we said that if f is a function and k is a positive number, then if I have a graph of y equal to f at s plus k, it means it's identical to the graph of y equal to f at x, except that it will translate k unit. Again, since this is f at s plus k, it will translate k unit upward. If it's y equal to f at s minus k, the f at s is the same. So we have a function y equal to f at s plus k, and we have another function y equal to f at x. Both functions will be the same. The shape of the function will be the same. But again, the y equal to f at s plus k will translate k units upward. Also, if we have the graph of y equal to f at s minus k, is the same as a function y equal to f at x. Again, the difference is that the function is going to translate minus k, so downward, k units. So plus k, let's say plus 2 means it to translate 2 upward. Then minus 2 means it to translate 2 downward. So the graph here can explain to us. So we can say our graph y equal to f at x, which is the red graph. We can say that is the same as the blue, and is the same as the green. So the group of three graphs here, the shapes are the same because it's y equal to f at x. But the blue is translated plus k. So it moves k times upward. The down one, green, is translated f at x minus k. So it moves k downward. So again, that's the concept of vertical translations. So let's see an example here. Here they say we should graph each function g at x equal to absolute x minus 2. So this means I'm going to first of all graph the function g at s equal to absolute x. Then I'm going to translate it 2 times downward. 2 times downward. The second one, we have h at s equal to absolute x plus 3. I'm going to translate it upward 3 times. So we are going to use the vertical translation of f at s equal to absolute value x. So that is the first function. I'm going to find the absolute x. And this is what we get. Absolute s, we are going to translate negative 2, so it went down twice. We know g at s equal to absolute x. It will be to start on the 0, center of origin. But minus 2, it will translate downwards twice. And the second example, we have plus 3. So it will translate up 3 times. So 1, 2, 3 upward because it's positive. So this means, again, any function we have, the first thing we need to do, for example, if I have a function f at s equal to s squared plus 3x, or in a bracket minus 6. This means first I'm going to find the function s squared plus 3 because everything is in a bracket. It's a function. Then I'm going to translate it whatever value I have. If it's positive downward, if it's positive upward, if it's negative downward. So let's move to using horizontal translation to graph functions also. So here we say that if f is a function and k is a positive number, then the graph of y equal to f at s minus k. Now here we should be careful. We can say that previously if I have y equal to f at x in a parenthesis, then minus k outside, then that's when it's going to translate again vertical, either upward or downward. But here we have x minus k inside the function. So this is identical to the graph of f at x, except that it's going to translate k units to the right. If it's minus, it will go to the right. And if it's positive, it will go to the left. So if we are graphing y equal to f at s plus k, then it's going to translate plus k to the right k times. To the left k times. So again, we have our original function, which is y equal to f at x. Now, next we have f at s minus k in a parenthesis. So this will translate again horizontal to the right. Then f at s plus k, everything in the parenthesis, it will translate horizontal to the left. Now, in our previous example, we have g at s equal to the function minus k. Now, minus 2 is outside. Let's see the theory, the definition. So if I have f at s plus k, this time the plus k is outside the x, f at x, the bracket. So in this case, it's going to translate vertically, upward. Minus k, downward. Now, if I have f at s plus k in a parenthesis, then it's going to translate horizontal to the left. F at s minus k, or in a parenthesis, also is translating horizontal to my right. And that's what we have here. Now, let's see an example. So here they say we should graph g at x. This time, s minus 4, everything in our absolute. Previously, we have g at x, absolute x, minus 4 outside. So after I find the function g at s, absolute x, I'm going to translate it 4 times downward. But in this case, I'm going to translate it to my left horizontal for 4 units. This is g at x, s plus 2. I'm going to translate it to my right 2 units horizontally. So this is what we get for x minus 4. We can see it move from the original 0 center to 4 because we translate it 4 times. And the same thing applies to the second one, plus 2. It goes to the left 2 units. So now let's graph functions using 2 translations. When we say 2 translations, it means we have both vertical and also horizontal. So when we look at this example, g at x equal to x minus 5q plus 4. Now we can see that s minus 5, it will translate 5 times to the right, horizontal. Then plus 4, it will translate upward 4 times. So let's start with the example. So the graph of g at x equal to s minus 5q plus 4 is identical to the graph of f at s equal to s cubed, except that it's going to translate 5 units. Again, the minus 5 is in the parentheses. So 5 units to the right. Then plus 4 outside the parentheses will be the vertical translation. Since it's plus, it's going to translate upward 4 units. So that's our answer here. So we have our original function f at s equal to s cubed. It will curve in the center of origin where we have s and y equal to 0. But now, since we are going to have minus 5, we are going to translate it 5 units to the right. And also we are going to have plus 4, and plus 4 outside the parentheses is going to translate vertically 4 units. So instead of the center in 0, 0, the center will be at 5 and 4, positive 5 and 4. Now, the next question said we should graph x plus 2 all square minus 2. So the first thing we're going to do is to graph h at s equal to s squared, s squared. So that would be a parabola. And since it's only s squared, it was the lowest part, first of all, is positive. So it will open upward. And the lowest part will be on the center of origin. But we have plus 2. Plus 2 means we have to shift to the left twice. So we move twice to the left. Then minus 2 means we have to shift downward twice. So we shift downward twice. So the intersection will be here. So the correct answer will be our green graph. Again, the shape of the graph is the same. The difference is we have minus 2 outside the parentheses. So we are shifting downward twice. And we have plus 2 in the parentheses. And that means we are shifting to the left twice. So that's what we have. To the left twice, downward twice. Now also we can use reflections about the x and y axis to a graph function. So a reflection again means a mirror image, or we will say something is symmetrical. So here we can see this graph here, y equal to f at s is symmetrical to y equal to negative f at s. So I may use the correct term reflection, the mirror image. So we say if we have a graph of y equal to negative f at x, now this negative affects all the elements in the function. So if the function is whatever s is, it affects everything. So if it's s cubed plus 3, it affects both. It's identical to the graph of y equal to f at s, except that it is reflected about the x-axis. Now the graph of y equal to f, now f at negative x, the negative is inside. It's identical to the graph of y equal to f at s, except that this time it is reflected about the y-axis. So that's the example here. I have my y equal to f at x. Now y equal to negative f at s, it will reflect to the corresponding to the x-axis. If I have y equal to f at x and I have y equal to negative f at negative x, it will reflect on the y-axis. So let's see an example here. They say we should graph g at x equal to negative. Again, the negative is outside the function, s plus 1. So first we need to plot the g at x. Then we find the reflection of it in the x. So first, the g at x, we can see it right here. G at s equal to negative s plus 1. Then we also have f at x. So if f at x gives me this, then the reflection of it will be, again, negative x plus 1 g at x. The goal we should know, one will reflect correspond to, if the negative is outside, it will reflect on x-axis. If the negative is inside, it will reflect through the y-axis. So in this question, it's outside. So the reflection is on the negative. So our actual function, f at s equal to s, again, this is absolute. So we get the red. And the reason why it's not in the original section, because it's plus 1. F at x, absolute x, will be on the center of origin when x and y equal to 0. But because we have plus 1, we have to shift it to the left once. Again, the plus 1 is inside the absolute. So we shift on the horizontal to the left. Now, if the plus 1 is outside the absolute, then we are going to shift it upward by 1 on y-axis. So we have done the s plus 1, shift it to the left. Then we have our answer. Now they say we should plot g at s equal to negative absolute s plus 1. So it will be a reflection on the x-axis. So we have the blue reflecting on the x-axis. That's the mirror image on x-axis. And the other one will give us the y, because the negative is inside. So the first I'm going to plot is s plus y absolute. Again, here is plus 1. So this is our function. F at s equal to s plus 1. Now negative s plus 1, we are going to have our reflection on y-axis corresponding to the y. So we can see how it is by 1 unit again. So again, that will be our conclusion on the concept of, again, translations. We saw how we can translate correspond to both s and y, and also we can translate both, depends the question they gave us. So again, wish everybody the best. Thank you.